the Federal Aviation Administration, FAA, has concluded its investigation into SpaceX's second Starship Super Heavy launch in November, paving the way for the company to proceed with its third test flight as early as mid-March. On February 26, the FAA announced the closure of the investigation into the November 18 launch, designated Orbital Flight Test, OFT-2, after accepting SpaceX's identification of the root causes behind the failure. SpaceX identified 7 corrective actions for the Super Heavy booster and 10 for the Starship upper stage. During the OFT-2 launch, the Super Heavy booster experienced a breakup during its controlled reentry and splashdown in the Gulf of Mexico, while the Starship upper stage suffered a fire and explosion triggered by liquid oxygen venting. Despite these challenges, SpaceX has worked diligently to address the issues. The corrective actions outlined by SpaceX and accepted by the FAA include hardware redesigns, operational changes, and updated analyses to enhance the robustness and safety of both the Super Heavy booster and the Starship upper stage. While neither SpaceX nor the FAA provided a specific timeline for completing the corrective actions and launching the third test flight, SpaceX CEO Elon Musk hinted at a potential launch in the second week of March. The upcoming launch will also include a propellant transfer test within Starship, potentially aligning with NASA's objectives for technology demonstration. Looking ahead, SpaceX aims to accelerate its rate of test flights, with plans for at least 9 launches proposed for 2024. The FAA remains engaged in the process, evaluating SpaceX's license modification request and working collaboratively to ensure the safety and success of future launches. Japan's slim moonlander has emerged from a frigid lunar night, signaling its resilience by sending back new photos to Earth. After nearly a month of hibernation, SLIM responded to commands, confirming its survival and communication capabilities despite temperatures plunging to 100 Celsius on the Moon's surface. In a playful exchange reminiscent of anthropomorphism, Jaxa, the Japan Aerospace Exploration Agency, shared updates on SLIM's status. The lander, referred to as alive and seemingly personified, communicated briefly before taking a break again. To prevent overheating, despite the challenges, SLIM continues its scientific mission, capturing fresh imagery of previously unseen lunar terrain. Utilizing its navigation camera, SLIM provides valuable insights into the Moon's surface. Although contact is limited until temperatures drop to safer levels, SLIM's journey has been eventful, from its precise landing on the rim of Scioli crater to an unexpected engine malfunction that left it upside down. Despite setbacks, its solar panels continue to generate power, albeit at a reduced rate. Following a brief operational period after revival, SLIM endured the lunar night, a period devoid of sunlight, before re-establishing contact with Earth. This remarkable recovery underscores SLIM's resilience, demonstrating its ability to withstand extreme lunar conditions. Having achieved its main objectives of precision landing, deploying rovers, and gathering scientific data, SLIM continues to contribute valuable insights into lunar exploration. India has revealed the names of 4 Air Force pilots selected to embark on the nation's inaugural space journey slated for next year, as part of the Gaganyaan mission. This mission aims to send 3 astronauts into a 400 km orbit for a 3-day duration. The Indian Space Research Organisation, ISRO, has been conducting various tests to prepare for the mission, including a successful test in October demonstrating crew safety measures in case of rocket malfunctions. Following this milestone, ISRO announced plans for a test flight involving a robot in 2024, followed by human astronauts in 2025. At a ceremony in Thiruvananthapuram, the 4 astronaut designates were hailed as courageous individuals ready to venture into space. Prime Minister Narendra Modi praised them as symbols of national pride, highlighting their role in representing the aspirations of 1.4 billion Indians in space. The selected officers, drawn from the Indian Air Force, include Group Captain Prashant Balakrishnan Nair, Group Captain Ajit Krishnan, Group Captain Angad Pratap, and Wing Commander Shubhanshu Shukla. They underwent rigorous physical and psychological evaluations before being chosen, and have since completed 13 months of intensive training in Russia. In addition, ISRO introduced Vyamitra, a female humanoid set to accompany future space missions. The Gaganyaan mission, named after the Sanskrit word for a vehicle to the sky, signifies India's significant investment in space exploration, costing 90 billion rupees. If successful, India will join the ranks of the Soviet Union, the US, and China as the fourth nation to send a human into space. India's space endeavors have garnered widespread attention, especially following recent achievements such as landing near the Moon's South Pole and launching Aditya L1, the nation's first Sun observation mission. With ambitious plans for a space station by 2035 and lunar exploration by 2040, India continues to demonstrate its commitment to space exploration and technological advancement. The Colorado Ultraviolet Transit Experiment (CUTE) mission, launched in September 2021, marks a groundbreaking achievement in the study of exoplanets. Designed by a team led by Dr. Kevin France at the University of Colorado Laboratory for Atmospheric and Space Physics, CUTE employs innovative technology to observe extreme exoplanets from a compact spacecraft. This mission aims to explore phenomena crucial to understanding the development and evolution of our solar system, such as atmospheric mass loss and interactions with host stars. Atmospheric escape, a fundamental process shaping planetary composition and evolution, is the focus of CUTE's observations. By pioneering the use of a novel rectangular Cassegrain telescope and a miniature spectrograph, CUTE overcomes the challenges of observing near ultraviolet light, crucial for studying escaping exoplanet atmospheres. The spacecraft's compact design, utilizing a 6U CubeSat form factor, enables precise measurements despite the thermal and pointing constraints of such a small package. Since its launch, CUTE has successfully conducted science operations, observing multiple transits of various exoplanetary systems. Notably, its observations of the ultra-hot exoplanet WASP 189b have revealed a highly extended atmosphere and evidence of active escape of heavy elements. These findings contribute significantly to our understanding of exoplanetary atmospheres and the processes driving atmospheric escape. Moreover, CUTE's success has paved the way for future small space missions, with its innovative design adopted by other projects, including NASA's monitoring activity from nearby stars with UV imaging and spectroscopy (MANTIS) mission. Additionally, CUTE prioritizes student training and early career mentorship, engaging over 20 students and professionals in various aspects of the mission, from science to engineering to operations. Overall, CUTE represents a significant advancement in exoplanet research, demonstrating the effectiveness of small spacecraft in conducting precise observations, and fostering collaboration and mentorship within the scientific community. Rocket Lab aims to launch its inaugural Neutron rocket by the year's end, according to their recent financial briefing. Progress on Neutron's development remains on track and within budget, with key milestones achieved in avionics, structures, and the construction of its launch pad at Wallops Island, Virginia. Although engine testing is pending, Rocket Lab aims to commence hot fire tests by March. Executives acknowledge the ambitious timeline, with the potential for delays, yet emphasize the strategic importance of launching before year-end to qualify for U.S. Space Force contracts. Furthermore, Rocket Lab announced a diverse range of spacecraft buses, reflecting their evolving vision beyond mere launch services. These buses cater to various mission profiles, with orders already in place. Rocket Lab's long-term goal extends to operating their own constellation, tapping into the lucrative space services market, which far exceeds that of launches and satellites. Neutron's development serves as a crucial step towards realizing this vision, enabling Rocket Lab to compete effectively in the evolving space economy. SpaceX successfully launched 24 Starlink Internet satellites from Florida on Sunday, marking the company's 18th mission of 2024. The Falcon 9 rocket carrying the satellites lifted off from Cape Canaveral Space Force Station at 5:06 p.m. Eastern Standard Time. After liftoff, the Falcon 9's first stage returned to Earth, making a vertical landing on the SpaceX drone ship A shortfall of Gravitas in the Atlantic Ocean. This marked the 13th successful launch and landing for this particular booster, with the majority of its flights dedicated to Starlink missions. Meanwhile, the rocket's upper stage continued its journey, deploying the satellites into low Earth orbit approximately 65 minutes after launch. This launch was part of SpaceX's ambitious goal to conduct 144 orbital missions in 2024. Notably, SpaceX recently achieved significant milestones with its 300th successful Falcon 9 liftoff, carrying an Indonesian telecom satellite, and tying its rocket reuse record with the 19th flight of a Falcon 9 first-stage booster during a Starlink launch.